Hello students, welcome to KENE'S Educare, a group of KENE solution. This is part 1 of lesson number 9, force and law of motion, laws of motion. Now, if you remember, the last lesson that we discussed was on motion. Everything we have discussed on motion in detail. Even the equations, there were some equations that we had discussed. We have discussed on the examples of motion. And before I start with this part, I hope every one of you have revised it and you all know the concept of motion properly, because that is what is needed over here, right? But along with motion, we also need one more concept. Like, we are going to study one more concept over here, and that is force. Okay, so what are we going to study in the lesson is about force and laws of motion. Now, as you know, the part 1 for the lesson is always going to be an introductory part, right? So I'll just like introduce the whole lesson to you, so that when I start with the exact lesson, every one of you are very much clear with whatever we are discussing, right? So the name of the lesson has two terms in it, force and motion. Now, I'm not telling you to write the laws of motion because I know that we haven't studied that, right? But you have studied about force and you have even studied about motion in your previous classes, or like in this standard itself, right? Class 9 itself. So I just want y'all to try and check whether you are able to write the definition for force and motion properly or not, because this is a test to yourself. I'm going to give you the definition, okay, but you should be even writing it by your, like, from your end as well. So I hope every one of you have started doing it. I hope every one of you are writing the definition for force and motion. And if you're not able to write it, no worries, no issues. Like, I'm going to help you with it. Okay, so it's okay if you're not able to write the definition. Because we are here to study itself, right? So how you can write the definition of forces, like each one of you can have different effect, because many of you might be knowing the definition of force as push or pull to an object, right? So in short, I can say that force is an effort that changes the state of an object at rest or at motion. What happens to force? Force is an effort. What happens in that effort? It's going to change the state of an object which is at rest or which is in motion. In motion means if they are moving. At rest means if they are stationary, they are not moving. So whatever effort is needed to change the state, either from a resting position or from motion, anything, what that effort which has been required over there, we know that as force. Okay, now remember one thing, that force can change an object's direction and velocity. Whenever we apply force to any object, what happens is we are able to change the direction as well as velocity of that object. Now let's suppose you have a table in front of you, or a book or a pencil. What you do, as soon as you apply little force on it, you will see that the direction and the velocity of the pencil or like your book will change, right? Why is it so? Because you're applying force, right? And remember one thing, that force can even change the shape of an object, like in case of dough. When your mom takes the wheat flour, adds water in it, water and oil in it, and she makes a dough out of it, and then from that dough we make puri, chapati and all, right? So that when she takes the wheat flour, she has to apply force to change its shape, right? The shape of the dough can change. So that is the best example that we can have over here, that force can also change the shape of an object. Okay, so this much part you can write, and then we'll proceed further with effects of force. But once you like write the definition, and like you write that force can change the direction and velocity of the object, and it can even change the shape of the object, just write this much, then I'll let you know more about it. I hope every one of you have started writing it. Like you have written it already, you can just add the points that I just told you. Once you complete with writing the additional points on force, like let's have a look on like the picture that has been given on the screen. Now can anyone like, do anyone know like what is exactly the scenario over here, or anything that you know about it? And guess the name of the person who is sitting as well. Let me see who knows this. Now we are going to write about the effects of force. So some effects of force include like, see, force can change the stationary object, the object which is at rest. If you like, suppose your book is at rest, right? If you apply force, you will change the position of it, right? You're going to move that stationary object. So you can write that force can move the stationary object. Force can stop the object from moving. Okay, force can like make it change and can even stop it from moving. Then force can change the shape of the body, and it can even change the direction. Now we have already discussed on the shape and the direction, right? Now we need like, you can add one thing, that force can even stop the object from moving, and it can even move the stationary object. Okay, so as I told you that some of you might be knowing the definition of force, like which is the simplest definition of force according to me, that force is like pull or a push. So we will be discussing on push and pull. I'll give you the proper definition and example of push and pull, because you know sometimes we get confused between a push and a pull, especially on the doors. Like when you enter the mall, there's push and pull written, like, and we get confused over there. So we will be discussing on the definition for push and pull along with the example. Okay, I hope every one of you are writing those that it can stop and it can even make the object move, right? After this, now let's write about push and pull, like how exactly you can define push and pull. I'll just let you know. I'll be dictating you the definition and I want each one of you to please write that in your book. Okay? So you can write that push is defined as an action or force which causes an object to move from its place. Like what is push? It's an action or force that allows an object to move from its place. And if I have to give an example of push, I can write like opening and closing the door, then pushing the table, pushing a car, pushing the thumb pins, walking, because while we walk, we push our legs, right? So these are some of the examples, and you can write the definition as action or force which causes an object to move from its place. And you can write the example. So sorry. Once you complete with push, we will even discuss on what exactly pull is. After this, you can define pull. Pull can be defined as an action to make move by either tugging or dragging. What happens in pull? Like it's an action again, and through this action we either tug something or we drag something. Like if I have to give the example of pull, I'll say plucking the string of guitar because there also we are pulling the string, right? Then pulling the ropes while playing the tug of war, opening the drawer, pulling the window curtains, opening and closing the door. Like here we have pull. So what you will write the definition as? Action to make or like move by either tugging it or by dragging it. And examples you can write, like if you have other example as well, you can add on to that as well. Like I don't have any issues with it. Okay. I hope everyone is writing the definition and examples of pull. After push and pull, like we will be discussing on the types of forces. Okay. I hope you all have understood properly what exactly pull and push is, because you know what happens? We understand all the concepts, but the basic concepts are left behind, right, in doing all those things. So I want you all to be clear with it. Okay. After this push and pull, we have the next thing to discuss, that is about the two different types of forces we can say, that is balanced force and unbalanced force. Okay. What do we have? Like we have balanced and unbalanced force. So see, balanced forces are applied to an object. Like when you are applying a balanced force to an object, there will be no effective force acting on that object, because you are applying a balanced force, so there will be no effective force acting on it. And hence balanced force do not cause a change in the motion. So that if it is balanced, like let's say in tug of war, if the force applied by both the team is going to be the same, there will be like no change, right? But if the other one, if that force becomes unbalanced, the other team will win, right? So remember this thing, that balanced force do not cause a change in the motion, and for unbalanced force acting on an object will change its speed or direction, because the force is unbalanced over there, right? So it's going to change the speed and direction of the motion, and it is going to move in the direction of the force with the highest magnitude. Okay, where will it move? Suppose team A and team B. So the force applied by team A is 400 Newton, and the force applied by team B is 300 Newton. So because team B is applying more force, that is 400 Newton, they will win because more force has been applied, and that becomes an unbalanced force. Okay, so you can just write this thing in your own words, explaining with you can say with the example of the tug of war itself. I hope you all are writing about balanced and unbalanced force. After this, like, we have to discuss on net force. Now, what do you understand by the term net force? Like, if I say like balanced force and unbalanced force, like you can understand that, like, just listening to balance, like the meaning of it becomes clear, right? But if what if I say about net force, what do you mean by that? So see, when multiple forces are acting on a body, we can resolve them into one component and we can call it as net force acting on that object. It means when I'm having multiple forces acting on my body, I'm going to consider it as a net force. Okay, I'm going to consider it into one component, which is known as the net force acting on the object. And the net force is going to decide the direction of the motion as well, like in which motion the force is going to act, that will be decided by it as well, by the net force itself. Okay, so you can write the definition for net force as: when multiple forces act on a body, they can be resolved into one component known as net force acting on the object. Okay, so I'm repeating it again. When multiple forces act on a body, they can be resolved into one component known as the net force acting on the object, and the net force is going to decide the direction of the motion as well. So after this, like, we will be, once you complete writing about the net force, we will discuss on like frictional force. Then we have the first law of motion that we will be discussing, which includes like inertia. We will be discussing about inertia and all. There are three different laws of motion which we are going to discuss in the lesson. Okay, but make sure you're writing this first and then we'll go through it. I hope you all are writing about the net force, and then we'll start with inertia and all, which are like again very important. Okay, like this much you will be studying for force, and then we have laws of motion, like under that we have inertia and three different laws that we will be discussing on. Okay, Okay. So after this, now have you heard about inertia before? Because like we will be discussing on laws of motion, right? So at that time, you need to know what is inertia, right? So before studying about inertia, I just missed out one type of force that we are going to study, and that is frictional force. So we are going to discuss on frictional force what exactly it is. Okay. So the force that opposes relative motion, what it is, the force that opposes relative motion is called friction, and it arises between the surfaces in contact. What are you going to write for frictional force? You know there's friction between the car and the road as well, because of which like the car keeps on moving, and we have two types of surfaces, like a smooth surface and a rough surface. And you might have seen that mostly the roads are rough, because that increases the friction between the road and the vehicle, because of which the vehicle keeps on moving, it cannot be smooth. Okay. So frictional force is like the force that opposes relative motion. Okay, what is friction? The force that opposes relative motion is called friction. What is friction? I'm telling you again. The force that opposes relative motion is called friction. Okay, and it arises between the surfaces in contact. How does the frictional force arises? It arises between the surfaces in contact. For example, if I say, when we try to push a table, okay, suppose you have a table in front of you. When we try to push a table and it does not move, right? Why you are not able to move it? Because it is balanced by the frictional force. Okay. So frictional forces, force that opposes the relative motion is called friction, and it arises between surfaces in contact. And you can write the example, like if we try to push a table and if it does not move, it is because it is balanced by the frictional force. Okay. So I want you all to write this, and then I'll tell you the laws of motion. Remember one thing, we have three laws of motion. Okay, we'll be discussing all of them, like in short, not in detail. Okay. I hope everyone is writing it. I hope every one of you are like writing about it. Okay, so now you can write like the first law of motion that we have is related to inertia somewhere. Okay, so see, a body continues to be in the state of rest or uniform motion in a straight line. Now suppose you are walking or any object is there, so that object is going to be in state of rest or uniform motion in a straight line unless acted upon by an external unbalanced force. We are going to like if you have an object which is moving or the object which is in the state of rest, okay, it is not going to move or it is not going to change its position unless and until we are not acting it, like it is not been acted upon by an external unbalanced force, right? So the first law is called as law of inertia. Okay, so law of inertia is also called known as the first law of motion, and it states that a body continues to be in the state of rest or uniform motion in a straight line unless acted upon by an external unbalanced force. I'm repeating this statement again. A body continues to be in the state of rest or uniform motion in a straight line unless acted upon by an external unbalanced force. And the first law is also called as law of inertia. What do we call it as? We also call the first law as law of inertia. So I want each one of you to please write it in your book, as it's very important for you all to know this point. I hope every one of you are writing it. I hope every one of you are writing about the law of inertia. That is the first law of motion. We will be discussing on the second and the third law as well, and then we'll move forward. After the first law, we can discuss on inertia, because as we discussed that first law is also called as law of inertia, right? So you should be knowing the meaning of inertia. So see, basically we know that all objects will have the tendency to resist the change. Like if you try to move it, if the object is in state of motion or it's at rest, it's going to change, it is going to try to resist that change, right? So that tendency of the object, we know it as inertia. And remember one thing, that all bodies do not have the same inertia, because inertia also depends upon the mass of a body. And we know that mass of an object is the measure of its inertia. So if you are like looking after the mass of any object, it is going to be the measure of its inertia itself. So more the mass, more inertia; less the mass, less inertia. Okay, so this is something important that you should be knowing. So you can write that all objects have a tendency to resist the change in the state of motion or rest, and this tendency of the object is called inertia. So, and you have to even mention it, that all the bodies, they do not have the same inertia. Okay, it is going to depend upon the mass of the body. So if the mass is more, inertia will be more; if the mass is less, inertia will be less. So please do take a note of it, because after this we have to discuss on inertia of rest and inertia of motion. Okay, so please be quick with it, everyone. I hope every one of you are writing about it. I hope every one of you are writing it. Now, after this, after studying the law of inertia and knowing about inertia, as I told you, we have two different things to discuss, that is inertia of rest and inertia of motion. Now, let's think that an object stays at rest, and we know that the object will be at rest until we are not applying any external force on it, right? Till that time, the object will be at rest. For example, when a car accelerates, passengers may feel as though their bodies are moving backward because the car has just accelerated, right? And whosoever is sitting in the car, they will feel like they are moving backward. But in reality, it's inertia which is making their body stay in place as the car is moving forward, because we know inertia is the opposite force, right? So it's because of inertia that their body is moving in the same place and the car is moving forward. So that becomes inertia of rest. And the another inertia that we have is inertia of motion. Now you know that the object will continue to be in motion until a force is acting on it. And like as soon as I'm going to like stop that force acting on it, the object will stop, right? The object will become at rest. For example, like if you have to know properly about inertia of motion, we can take one example of a hockey puck. So that hockey puck will continue to slide across the ice until acted upon by an outside force, right? So you can write about inertia of rest and inertia of motion quickly. I hope every one of you are writing it. I hope every one of you have written it. Now the next thing that we have to discuss is the second law of motion. Okay, so I'll just tell you what does it state. Okay, so, and remember one thing, like before discussing on the second law, we will be discussing on momentum as well. Because unless and until you not know what momentum is, you won't understand the second law of motion. But for now, as we know that we are going to discuss the three laws of motion, as this is an introductory part, we are going to discuss all the three motions in like three law of motion in detail. Okay, but I'm not telling you about momentum in that detail now. Okay, I'll just tell you what is momentum. Like momentum be represented by p, small p. Okay, and that is equal to, like you can define momentum of an object as product of its mass and velocity. What is momentum? Product of its mass and velocity is momentum of an object. Know this thing about momentum now. Now I'm telling you about the second law of motion, what exactly it states. Okay, so I want you all to even take a note of this as well. You know, the rate of change of momentum of an object is directly proportional. What I'm telling you, the rate of change of momentum of an object, the rate at which the momentum of the object is changing, is directly proportional to applied unbalanced force in the direction of the force. Okay, the rate of change of momentum is directly proportional to applied unbalanced force in the direction of the force. Okay, so I just want you all to take the law, and then I'll even give you the third law of motion. After that, I'll stop for today. Okay, so sorry, I hope you all are writing the second law. I hope every one of you are writing it. Now we have one more law to discuss further, but I hope you are clear with the first two law that we discussed so far. See, now as I told you that we have one more law to discuss, right? So you can start writing the third law that I'm telling you, and please try and understand the law. Okay? So the third law of motion states that every action has an equal and opposite reaction. What does the third law states? That every action has an equal and opposite reaction. So action and reaction are equal, opposite, and acting on the different bodies. Now this is one of the like most famous Newton's law that we have, that every action has an equal and opposite reaction. Okay, so you can just write that in your book as well, and then we'll proceed further. I'll just like show you all the slides of the screen, and then I'll stop for the day. Okay, so now I'm going to show you all the slides one by one, and I want each one of you to please go through it properly. Okay, so we are going to start the lesson by discussing about force and about the thing that we discussed so far. Okay, that is the like what force can actually do on the body, right? So we'll discuss on that. Then the effects of force can be understood by the following points. So these are the points that I like already made you revise, right? So I want you all to please go through it as well. And then after this effects of force, we will discuss on the two types of force that we did today as well, right? So we'll discuss on the two types of forces, that is about the balanced force and the unbalanced force in detail. Okay, so here we have balanced and unbalanced force that we'll discuss on, and after this we'll discuss on the first law of motion, what exactly the first law of motion states. We'll discuss that. Then after this first law of motion, like it's in detail, right? It's not in short, so we'll be discussing all of that in detail. Then we have activity 9.1 to discuss in detail. After this activity, we have 9.2 activity again, which we will be discussing on. Then we have activity 9.3 to discuss. Okay. Then after this activity 9.3, we'll be discussing on inertia and mass, like what exactly they are. So after this inertia and mass, we'll discuss on the second law of motion as well, what exactly like it is. Today we just you can say discussed on we just discussed on the statement, right? But in the next class we'll discuss on more about it. Okay, then after the second law of motion we will discuss the mathematical formulation of second law of motion in detail, of what exactly it is. Okay, then after that we will discuss about second law of motion along with examples and all. So here we have example where we'll be like discussing on how to calculate the final velocity of the object. Then after that we will be finding out that which will require a greater force, okay, from both. So we'll discuss on that as well. And then we have 9.3, 9.4, 9.5, and after that we have the next thing to discuss, that is the third law of motion. Okay, after this third law we will discuss on activity 9.4 as well in detail. Okay, then we will discuss on like conservation of momentum in detail. Okay, after discussing on conservation of momentum, we will discuss on activity 9.5, 9.6, and then we have the next thing, that is 9.6, 9.7, 9.8, and then the summary discussion. So just imagine how many, you can say, how many things, how many examples that we have to discuss, right? We'll be discussing on all of it, and then we have some exercise question that we will discuss, and that is how we will be ending up with the lesson. Okay, After this, like, here are like few of the, you can say, exercise questions which have been given. So I want each one of you to please go through it quickly. I hope you all are going through the question that I have like shared it on screen. See, I'm showing you the questions before so that you know what are the types of like questions we have and what are we exactly going to study. As this was the introductory part, now you know, like, you're aware of the lesson that we are going to study, right? I hope every one of you are going through it. So total we have like 18 questions that we will be discussing at the end of the lesson. And I hope like whatever we discussed now, every one of you are very much clear with this part, like this part of the lesson, right? So now I will be starting with the exact lesson that is in the next part. So make sure before you like start watching that part 2, you're clear with all the basics that we just discussed now, because it's very important for you to know those part. Okay, so I'll end the session over here, and please make sure you revise it. Okay, so I'll continue with the rest of the part for the lesson force and laws of motion in the next part. Thank you everyone.